Okay, so we'll start from. Okay, so if you want to deploy, if you want to write a like we write the code and we write that code into the file. Okay, so that file called program file. If you execute that file, that file become an application that apply your application. So if you want to run application to make the clients to be access, okay, okay. So we need to save this. We need to put this application in somewhere that location is called server. That location is called server. So if you want to deploy your application, we need infrastructure like CPU, RAM, storage, hardware, network, firewall. So this is the complete package is nothing but a infrastructure. So we need infrastructure. Okay. So traditional. So earlier people ఏం చేసేవాళ్ళంటే the CPU, RAM, network storage తీసుకొని as a hardware, they'll install OS. On top of that, if you want to deploy your Java application, for example, so they will be installing Java related libraries, softwares, okay, on top of the OS. So then they deploy their application. Okay, so they take this laptop or desktop or instance with the 10 GB RAM, 4 CPUs, 500 GB resources they allocated to this machine. Okay, so but as we observe, okay, the application is not consuming 100% of resources. They are consuming 5 GB RAM, 2 CPUs, 100 GB storage only. Okay, so here the resource utilization is very low, very less. The resource wastage is very high. Here we are wasting the resources, right? ఇక్కడ మనకు 5 GB ర్యామ్ స్టోర్ యూజ్ చేసుకుంటుంది కదా. సో I can deploy one more application. So I can deploy one more application and I can use my application over there. So it will be like the resource utilization I'm making not too less. Okay, I'll make resource to be used in a proper way, in efficient way. Okay, so that's what I mentioned traditional deployment. The traditional deployment, you cannot deploy multiple applications into the same machine. Okay, you cannot deploy multiple applications into the same application, same instance, same laptop, same desktop, same physical machine. Okay, so in real time, what we used to do earlier, so we need to make isolation. We need to make isolation. Isolation and where there will be no connection between two instances, like so deploying multiple applications in a different instances, different physical machines. Okay, so we had many times about isolation, like in a corona time, like so they put person into the isolation, this guy into the isolation. Isolation is in a sense keeping the persons in a separate environment, separate room. So that become a isolation. Okay. So in a real time, in the traditional model, so we were not deploying our application into the multiple applications into the same server. Okay. So we should we make those applications to be isolated. Okay. So isolation from each other. So we create one, like, so we will be having one more instance. We will deploy another application. We will deploy another application. So this is completely different. This is completely different instance. So it will be isolated. This application is strictly to that instance. This application is strictly to this particular instance. So we used to isolated our application. Okay. So to isolate your application. to isolate your application. Okay. So again we need CPU, RAM, storage, okay, network, firewalls. We need all of that. So again, we will install our OAS. On top of that, we will deploy our application. So the other application. Okay. So now we are making isolation between two instances. So we used to follow this in earlier. So here also we allocated some resources like 10 GB RAM. So the application is not taking that much the resources. So here also we are wasting our, see, if you have 10 instances, how much money you are wasting? How much money you are wasting to deploy your application, to run your application. Okay. So you, okay. So we need like, so this this is one, we deploy OS and we deploy our Python application over there. And on top of that, we deploy Python. On top of that, we will run Python program. Python program means Python application. Okay. So this is OS. On top of that, install Python to run Python application. To run Python application. So you need to install Python software. Okay. On top of that, our application will deploy. Our application will deploy. Python application will be deployed. So here also we allocated same 10 GB RAM. Okay. 10 GB RAM, 4 CPUs, 4 CPUs, 4 CPUs. Okay. 400 GB storage. 400 GB storage. Okay. But application is not consuming that much resources. So here we are wasting the resources. Okay. So we should make our application to be isolated. So we make our applications to be isolated. This is running in one machine. This is running in another machine. So there will be no connection. It is isolated from together. There is a isolation from together. Okay. So this is one machine and this is one machine. So there is a isolation from each other. So they'll be running in their individual machines. Okay. So in real time, so we used to not deploy our applications onto the same machines due to some reasons like any network issues, storage issues. We don't know which application consuming more resources during high request. Okay. So here we are wasting our resources. Okay. So if you want to deploy one more application, so you need to buy one more the instance or one more laptop or one more desktop. Again, you need to perform all this. Okay. So you buy physical machine with, for example, 10 GB RAM, 4 CPUs, 500 GB RAM, 500 GB storage. Because we don't know like how the application will be grow up, how the application will be famous. Okay. Uh, so due to that reason, people used to buy physical machines with the huge resources. Okay, but they used to deploy one application per one instance. Okay, so after that, after that, దాని తర్వాత ఏం చేశారండి? This is a traditional deployment. Okay, traditional deployment where we used to do wow. like almost 10 years back, or 10 years back. Okay. So after that, to overcome this resource utilization, to overcome this resource utilization, okay, issues, to use that resource properly, what people has done is, okay, so they move to virtualization. They move to virtualization. మీరు వినే ఉండరు. సో వర్చువలైజేషన్ అనేది, virtualization. Okay. So they move virtualization deployment model, traditional model, where one application, one server, where we used to make our applications to be run in an isolated manner. Okay. So virtualization. So they move to virtualization model to deploy their application, and use the resources properly. So in the virtualization, what they have done is, what they have done is, okay, so they have I'll take one more, I'll take one more thing. Okay, so in virtualization, okay, in virtualization, what they have done, okay, in virtualization, what they have done, okay, so they create they have uh, s- like hardware in a sense, network, CPU, like all of that, CPU, RAM, network, network, okay, storage, firewalls, firewalls, firewall in a sense, security groups. Okay, so they on top of that they we install OS. Anyways, without OS you cannot run any program in the entire world. Okay, so whether it is mobile or whether it is any laptop or any, so without OS you cannot run any program. We need OS to run our program, nothing else we use. Okay, why we use our laptop? To run any application. Why we use our mobile? So to run some application. That's it, nothing else. We don't do anything with that. Okay, so if you play the video, that is kind of one application. Okay, so if you want to use OS, so OS is only one purpose, that is used to run your application. So we then this is virtualization. Okay, virtualization deployment, virtualization deployment model. We move to this. Okay, we move to this. Okay, so in the virtualization law, in this element. Okay, so on top of that, uh, they used to deploy hypervisor. They used to deploy hypervisor. Okay, they used to deploy hypervisor. Okay, so you might aware like so hypervisor. Even even cloud AWS also run on the hypervisor only, where you get multiple instances, right? If you want. So they use hypervisor called Zen. Zen is the hypervisor they use. Okay. So they have hypervisor as a virtualization for virtualization. So that's what you are getting, that many machines. Okay. So the people used to deploy virtualization On top of that OS, they used to deploy hypervisor or VMwares. We are already aware that VMwares, virtual machine wares, VMwares. Okay, so on top of that, what they used to do, they used to deploy guest OS. They used to deploy guest OSs. You can deploy as much as you want guest OSs. Okay, this is one guest OS. I'm just giving GOS means guest OS. Guest OS. Guest OS. Guest OS. Guest OS. Okay, so for each guest OS, they allocated some resources like CPU, RAM, storage. They used to allocate for for like all of them for all the machines for the all the OSs. So they used to some allocate some resources. Whenever you create the guest OS, okay, the guest OS, so it will ask you to allocate the resources. How much CPU, how much RAM, how much storage, what is the network. So it will ask you to set up that guest OS. When we set up guest OS, it will ask. We will allocate those resources for each guest OS. So on top of that, we will install our dependencies. On top of that, we install our dependencies, our softwares. Okay, our softwares, we used to run this. Okay, whether it is Windows OS, whether it is Windows OS, okay, or whether it is Mac OS, sorry, Linux, whether it is Linux, okay. So Windows OS, so we will install our softwares, okay, we will install our softwares or libraries on top of the guest OS, okay, guest OS. So on top of that, if it is a software related to the Python, so we used to deploy our Python application on top of this, on top of this. This is a this is a virtualization where earlier we used to use only one machine for one application. Now, when the virtualization facility is provided, you can use same machine. You can deploy multiple applications as you want, as you want. Okay, so this is one app one, for example. Okay, so this is app two, app app two. Okay, and this is for app two. This is for app three. This is for app three. Okay, so they follow this model into the virtualization as well. Into the virtualization as well. Okay, so while creating this guest OSs and all, we used to allocate the resources. Okay, so each OS is separate. Each this OS is separate. This OS is separate. This OS is separate. So isolation also we made. Isolation also we made. Okay. Now app one is different. App one is running in the different isolation. App two is running in the different isolation. App three is running in the different room. Okay. Different room. It means we made our applications to be run in isolated from each other. From each other. Okay. We made that. Okay. So here when we create this, like here we need to buy multiple OSs. We need to buy multiple OSs. Okay, multiple OSs we need to buy, right? Multiple OSs we need to buy, right? So it means how much cost it will be. If you want to buy multiple OSs, so how much cost it would be. So we are wasting the like in terms of the cost, we are wasting our cost, right? To to install our OS to install our OS. Okay, so for each guest OS, so we are buying it. That OS we need to buy, right? We need to buy that OS. Okay, so here hypervisor is doing the virtualization. Who is doing? Hypervisor is doing the virtualization. Okay, hypervisor is doing the virtualization at the hardware level. Okay, so each application. So here you need to buy multiple OSs. So you need to spend lot of cost on that. Okay, you need to buy lot of cost on that. Like if any guest OS, any application goes down. Okay, so in traditional deployment or in virtualization. Okay, you need to get one more machine. You need to get one more. You need to get. You need to create one more instance. You need to create one more instance. Okay, and you need to install OS, and you need to run. You need to install softwares, and you need to apply. You need to install the application. So how much time it will take? How much time it will take? It will take around 30 minutes, for example. It will take 30 minutes, for example. It will take 30 minutes. Okay. So for all the machines, this is the one this is the one virtual machine, and VM1, and this is one virtual machine. This is one virtual machine, and this is one virtual machine. So for all the machines, the hardware will be the same. Okay, the for all the machines, for the all the virtual machines, the hardware will be the same. Okay, so that's what the hypervisor is doing virtualization at the hardware level. At the hardware level. Okay, so in virtualization, there is no there is no link between guest OS and base OS. This is host OS. This is host OS, and this is the guest OS. This is a host OS and guest OS. There will be no link because there is a hypervisor in between. There is no link between guest OS and host OS. For guest OS, we already allocated some resources. We have already allocated some resources. Okay, so if we allocate these resources from the host OS only, from host OS only. Okay, so we allocated. You can think. So we took 10 GB RAM. So for 2 GB we allocated what one virtual machine one. For 2 GB we allocated virtual machine two. For 1 GB for 2 GB we allocated for virtual machine three. We allocated. So for each virtual machine we are allocating some resources from the base OS only. Okay. So if guest wise required resources, we will allocate from the host OS, from the host OS. Okay, but there will be no link between guest OS and host OS. So the hypervisor, the VMware will take care of the connections, the connections. Okay, so if you want to buy multiple OSs, so you need to buy them. So you need to waste lot of money. You are wasting lot of money. Okay, so and Host OS as some kernel. So what is kernel? Host OS as kernel. So kernel ఏంటి అంటే సో ఒక మనిషికి హార్ట్ ఎలానో సో ఓఎస్ కూడా కెర్నల్ అలాను. ఓకే, ఎవ్రీథింగ్ విల్ బి టేకింగ్ కేర్ బై కెర్నల్. The hardware, allocations, everything will be taken care by the kernel. So host OS has kernel, and so we install guest OS. Each guest OS also have the kernel. Host OS also have the kernel. Host OS, guest OS is also have the kernel. Okay, guest OS is also having kernel. Kernel is a part of the operating system which will be taking care by all the requests coming from the user. Okay, so what is the disadvantage with this traditional mode? So you install multiple OSs, right? So you need to buy them. So you are wasting money. And so you have multiple kernels. So and you have deployed multiple virtual machines on the same machine. It means don't expect much performance, faster, faster performance from the virtualization. We resolve the issues like where one application to the multiple applications to be deployed into the same instance. Okay, but here we deployed multiple applications. That is fine. That is absolutely fine. But don't expect much performance from the virtualization. So we disadvantage like performance. Okay, performance. Performance will be slow anyways. Okay, and fixed storage. Fixed storage. Okay, so RAM and CPU you can get it. You can get it from hardware. Like if required, the hypervisor will go and get that. But storage will be allocated fixed. You cannot change that. You cannot change that. For example, if the storage exceeded, if you allocated 500 GB exceeded, then you need to create one more virtual machine with the 1000 GB. Okay, so to get that new machine, so it will take 30 minutes. In traditional model also, if you deploy your application, taking this buying this laptop or desktop, installing softwares, run your application. Okay, so whole it will take a lot of time. It will take lot of time. So, for example, generally we create our instance in the E- AWS, right? So how long it will take? It will take minimum 5 minutes, right? Like minimum like 2 or 3 minutes it will take to create an instance and to get to come that instance to be running state. It will take minimum 2 minutes. It will take, right? So in real time world nowadays, okay, if application goes 2 minutes or 3 minutes, so how much impact they have? How much impact they have? For example, Amazon goes down for 2 minutes. How much money they lost? How much profit they lost? Right? So for 2 minutes, millions of people will connect to the Amazon. They'll buy products. Okay. So if that 2 minutes goes down, the 2 million people will not connect to that application. They cannot buy anything. They'll move to another uh, e-commerce application like Flipkart. Okay. So they can buy the product from there. Okay. So that kind of impact they have, they used to get. Okay. So now we're in a faster world. So where it should not take, if you want to set up your OS, here we need to you take the hardware, and if you want to install your OS, if you want to install your OS, it will take 30 minutes. installing OS and get that machine, install some softwares and install application. It will take 30 minutes to come that application up. Okay. So for example, you take this, uh, generally మనం ఇన్స్టెన్స్ క్రియేట్ చేసేటప్పుడు we take one Ubuntu or Amazon Linux image, right? So we can take this, we can take this as an image. We can take this as an image. Okay. We can take this as an image. This entire system, we can take it as an image. That image become an ISO. That become that, and that instance become an ISO. Dot ISO image. Dot ISO image, but it will be dot ISO image. It will be like 3 GB or 4 GB or in size. It will be 4 GB or 4 GB or 5 GB, so 4 GB or 5 GB in size. Okay, so if you want to move this 4 GB or 5 GB to another location, like for example, if they like they created one machine, okay, from into, if they want to get that image to that instance, okay, they should download 4 GB or 5 GB size in their machine. So how long this will take? It will take some time to download this EMA. So this size will be very huge. Okay, and installing, taking this, taking this ISO, installing the new machine, new machine, okay, new machine, new machine, it will take around 20 minutes, around 20 minutes. So the customer should wait for 20 minutes to get their application to be up. Okay, so if you want to move this ISO from one location to another location, it will be very hard to move, right? Very hard to move. 4 GB or 5 GB అంటే అప్పట్లో ఉన్న నెట్వర్క్ బ్యాండ్విడ్త్ కి, సో అది వెరీ హ్యూజ్ టాస్క్ అన్నమాట. ఓకే, అది వెరీ హ్యూజ్ టాస్క్. ఎందుకంటే సైజ్ అనేది చాలా హెవీ. It won't create 1 MB, 2 MB of ISO images. It will create minimum 2 GB ISO images they used to create. So from that, they used to create multiple instances from the on top of the virtual machines. So to move these ISO images, to store these ISO images, so they used to waste the storage. They used to waste the storage. So to get this OSS, to get this, get one more machine to be up and running, it will take 30 minutes. It will take 30 minutes. I don't want 30 minutes to be waste of customers. Okay, so I want my OS, like so as we know, hardware plus OS, if you make this, it is nothing but a image, right? AMI, AMI. So if you combine this, it will become a AMI. Okay, so OS also some programs. So that's what I mentioned, hardware. Okay, so I don't want to install my OS not to take 1 second. 1 second. So if you want to deploy your, if you want to install your OS, it should be done in a 1 second. I'm talking about 1 second, not 30 minutes, not 1 minute, not 2 seconds. It should take 1 minute. Okay, to set up your OS, earlier it used to take 30 minutes of time to get our application to be run. Now, if you want to deploy, if you want to install your OS, it will take 1 second to get your OS up and running. Your OS, your OS means it is an instance to up and run in 1 second. You want to install your OS, that will take 1 second. Okay, how this will work? How this will work? So what we will do? So we have hardware, hardware in a sense, CPU, RAM, everything. Okay, so we have hardware. Okay, hardware in a sense, CPU, RAM, storage, network, and all. So on top of that, we install our OS. We install our OS. That OS called host OS. Host OS. Host OS. Okay. On top of that, on top of that, instead of hypervisor, we install Docker. So we use Docker. Docker is a platform, okay, where it will provide your applications to be run in an isolated manner, and it won't consume more resource utilizations. And if you want to install your OS, it will not take more than 1 second. Within a 1 second, your OS will come, install, and up and running within 1 second. Okay, so on top of that, we install Docker. Okay, so on top of that, on top of that, we will create as many as you want, whether it is Windows machine or whether it is Linux machines, whatever. So this this box, whatever the box we this box contain, this box contain, okay, this box contain um, Python. If you want to run Python application, it has the Python libraries. Okay, Python libraries. Okay, on top of that, you can install your application. You can install your application. This box called this box called container. This box called container. So what it is? The container has the application along with the dependencies and the runtime. Runtime means the component which needed to run the respective language application. If it is Java, Java runtime should be there. If it is Python, Python runtime should be there. Okay, so it has app, and along with the libraries, what dependencies, softwares which required for to run your application. Okay, so this container is separate. This container is separate. This container is separate. Okay, so now isolation happened. Isolation happened. So this is isolated from this. This is isolated from this. So each application is running in the isolated manner. But 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 Docker use host OS only. Docker will use host OS only. Okay, Docker use host OS only, and the host OS has the access for Docker, which is read-only access only. Read-only access. The Docker will not write anything to the host OS. It is having read-only copy. Okay, Docker using the host OS, but it will take as a read-only copy. On top of that, it will take read-only copy. Read-only copy. Okay, so container is isolated, and container doesn't have, like, so container in a sense, consider this is one instance. Container is nothing but an instance. Container is nothing but an instance, right? So general ga instance will have OS means it has some kernel. It has some kernel, right? It has some kernel. But the kernel, but the container will not be having kernel. Container will not be having kernel. No kernel. No kernel. Okay, no kernel. So the container will use, okay, container will use base OS, the host OS kernel only. Okay, so the container will share the kernel. Okay, container will use the host OS kernel. Okay, so it is a shared kernel. It is a shared kernel. Shared kernel between host OS and kernel. Host OS and container. Okay, so the host OS only have the kernel, and it is shared with all these containers. All this container. It is a shared kernel.